Hey gang, so I thought I'd do a little more complicated circuit than I've done in the past, where we get to use all three of those principles: Kirchhoff's voltage law, Kirchhoff's current law, and Ohm's law. So here is our circuit that we're going to try to analyze. And the question I'd like you to try to solve is the following: find all, I repeat, all voltages and currents. You can't see the currents anymore, but it says currents. Currents in the circuit. So we have four different elements, and I give you that guy, 30 volts. That's a power supply, and the voltages are already labeled for you. So we need to find V1, which is the voltage across there, V2, the voltage across that resistor, and V3, the voltage across that resistor. But I also want you to find currents. So let's go ahead and identify the currents I want you to find. So we have a current going through here that goes through that resistor. Okay, let's call that I1. Ooh, tiny. And then we have the current going down this resistor. Let's call that I2, right? It's coming down through here. And then there's a current going out of that node, or it could be going in, but I'm going to go ahead and point it this way, I3. Okay, so those are our three currents. You have a current here, and then you have the two currents here, right? This one and that one. So three currents to worry about in our system. And again, the polarities as indicated for the voltages are kind of arbitrary, and if we solve for these voltages and it turns out we have a negative voltage, all that means is that we need to reverse how we drew the polarity here. Same thing with the currents. I drew the current going into this node that way, and then out of it that way, and then out of it this way. But then if we solve for I's, if they turn out to be negative, then we just have to reverse the way we drew them. So where do you start? Give all these variables, right? 6, 3 voltages, 3 currents. So how do you start to figure out what to do? The brute force approach to this, which I'll go through, is to write down all the relationships you can between all the variables. Let's start off with something simple. For instance, we know, should we use the black pen in this case? We know we can apply Kirchhoff's current law in here and look at that node. Well, the way I drew it, there's only one current going into that node, right, I1. So the current going in has to equal the currents going out, and based off the way I drew it, the currents going out are I2 and I3. Again, don't worry if we drew them wrong. If we labeled the direction of the currents wrong, we'll figure it out by having negative currents if we are wrong. So that's one relationship. Well, what else do we know here? Well, let's apply Kirchhoff's voltage law. Do you see how many loops we have to deal with here? 2 loops. And I'm going to define the loops going in that direction. So that's loop 1, and then this guy, loop 2, just so you can follow along. Okay, so let's add up all the voltages around loop 1. Remember, they have to equal to 0. So loop 1, if we go around this way, we have 8 volts. And then going on this way, we have, not 8 volts, V1, because that's unknown. V1, and then going down this way, we have V2. And then going up this way, the polarity is different now. Remember, positive to minus, and then minus to positive, so that means you have to subtract that 30 volts. And we know that equals to 0. How about the second loop? Well, let's take a look at the loop as we go around this way. Positive or minus? So V3. Positive, no, not positive, minus. We labeled it minus to positive, so we're going to have to minus V2 equals to 0. Okay, well, do we have enough to solve for all of our variables? No, we only have 3 equations, and we have like 6 variables here. So what else do we know? What other equations can we write, or relationships can we write about? Well, luckily, hopefully, you know Ohm's law. And based off Ohm's law, we can develop a relationship or write a relationship between current, voltage, and resistance here. So V1 equals the current going through here, which we defined as I1, times that resistance, which is 8. And then we know V2, which is that voltage down there, equals I, which we defined as I2, times this resistance, which is 3 ohms. And then we have one more relationship we can write about that maybe you cannot see. There you go. V3 equals I, and we define this I that's going through this resistor as I3, way up there from earlier in the video. I3, that's the current going through here. So I3 times this resistance is 6, right? So I3 times 6 equals that voltage drop across there. Ah, well that's better. Okay, because now we have 1, 2, 3, 4, 5, 6 equations and 6 variables that we can mathematically solve. Now, where do you start? How do you start solving stuff? Well, we want to eventually get to one equation with one variable. So we have to slowly work our way through this, which means I might need to have extra paper handy. But there's some really interesting relationships we can start with. For instance, this guy. Hey, V3 minus V2 equals 0. Well, that kind of means V3 equals V2. Well, that's good to know, so we have that handy. Well, what else here? Well, if V3 equals V2, we can use Ohm's law in here maybe to get it into current. So V3 is I3 times 6 equals V2, which is I2 times 3. And we can solve for one of these guys. We can solve for, let's solve for I2. Okay, so I2 equals, and the 6 divided by 3. So 2I3. Oops, kind of weird how I use the parentheses. But that's okay. You know what I mean, right? I2 equals 2I3. Well, that's another relationship we can use. Well, why don't we just start from there? So we've solved for I2 in terms of I3. So how about we try to come up with an equation, one equation, where all we have is I3. So what we do to get everything in terms of I3? Well, how about up here? I1 is in terms of I3, but we know I2 equals 2 times I3. So how about I1 equals 2I3, because I2 equals 2 times I3, plus I3. Huh, very cool. Now we have I1 equals 3 times I3. Well, that's useful to know. So we know I1 equals 3 times I3. We know I2 equals 2 times I3. And that's actually enough to get us someplace. Where do you want to go from here? Well, let's use this equation. Let's use that equation. This might actually be a long about way of doing it, but there's no one right approach. There's lots of ways to solve all of these equations. So let's take a look at that, dude. So V1 we can replace. I'll put that down here, right? Oops, down there. V1 we can replace with I1 times 8. V2 we can replace with I2 times 3 minus 30 equals 0. And we know we can replace both of these guys with I3s. And I1 equals 3 times I3. So that's 3 times I3 times 8 plus I2, which we know right here is 2 times I3. So 2 times I3 times 3 minus 30 equals 0. Okay, one equation, one variable, we're golden. Oops, you can't see that. Ah, there you go. All right. 3 times I3, because that is equivalent to I1 based off that equation, 3 times I3. And then I2 times 3 Well, I2 we know is 2 times I3, so 2 times I3. So now we have one equation with just one variable. Let's rewrite this. So 24 I3 plus 2 times 3, 6 I3 minus 30 equals 0. Okay, combine these guys, so that equals 30 I3. 30 I3. And then we can move the 30 to the other side here. Follow the arrows. So 30 I3 equals 30. Well, that means if you take 30 divided by both sides, I3 equals, as I move the paper for you, equals 30 divided by 30, which is 1. Bam, 1 amp. All that for 1 amp. Okay, so now we know I3 is 1 amp. Now everything's going to be simple. Yeah, where's my thumbs? Thumbs up, simple. Okay, so if I3 equals 1 amp, then we know I1 has to be, let's move it down for you a little bit. So where I just left off before I was rudely interrupted by the fact that I'm running out of space on the paper is we solved for I3. We found out I3 equals 1 amp, and now we can use that to solve for other variables. So for instance, up here, using our KCL equation, we notice that I1 equals 3 times I3. So let's move to new paper. So I1 equals 3 times I3, and we know I3 is just 1 amp, way down there, 1 amp. So let's go ahead and put 1 amp here. So that means 3 times 1. So I1 equals 3 amps. Okay, so that's good. We have I1. We know I3 equals 1 amp. So how about I2? Well, we have a relationship for I2, don't we? Right here. We said that, that I2 equals 2 times I3. Okay, so 2 times I3, huh? 2 times I3, and I3 is 1. So that just gives us 2 amps. So now we have all 3 currents. Well, that was simple. We have I1 equals I3, we have I3 equals 1 amp, and we have, I said that funny. We have I1 equals 3 amps, we have I3 equals 1 amp, and we have I2 equals 2 amps. Fantastic. And now we can use Ohm's law to solve for all our voltages. Or can you see right there? Voltages. So V1. Well, we know V1 equals I1 times 8. So I1 we know is 3 amps times 8, right? 3 amps, we just solved for it. That means the first voltage is 24. That's kind of high. V2, using Ohm's law, right there, is I2, which we just solved for as being 2 amps. So 2 amps times 3, that is 6. Let's make sure some units in here. 6 volts. So V2, in case you didn't see that, equals I, which is 2 amps, right there, times the resistance, which is 3 ohms, equals 6 volts. And then the last one is for V3. V3 equals I3 times 6. So V3 equals I3, which is 1 amp, times 6 ohms, because that's what we had in the original circuit for the resistor, right there. This equals 6 volts. So now we have all the voltages, and in a messy way that I wrote it, we have all the currents. I3 equals 3 amps. I1 equals 3 amps. I3 equals 1 amp. And then I2 equals 2 amps. Voila. It just took a little longer than I was hoping with more paper. But hopefully that helps a little bit.